Hello everyone. This is the simplest program you can write in Go. It's called Hello World. Let's first run it. Go run a.go. It runs and it prints out Hello World. Now, this is A. This is not the convenient way of calling this. This should be called main, but don't have to be. It's not obligatory, but this is the convenience. To call this file main. However, the main package is a special package in Go. It's the main entry point of every Go program. This tells Go that, hey, this folder is the main entry point of the program. And then there is this function that's the entry point or the entry function to the program. It means this is going to run the first in our program, then the rest. Now, this FMT is we are importing a package. It's called FMT or format. If you are coming from C or C++ background or something like that, you are probably familiar with that. And now we are printing out hello world. We can visit this and see it's printing out to the OS std out. Now, few things. First of all, any or every program running in the computer opens out 3 files. So there is the std out. So these are comments, like you can see stdr, stdin. Okay, so these 3 files gets opened. Whatever programming language you use, whatever program you write, this gets opened. These 2 to print out, and this one to print, like to print in or to write to the program. So like your keyboard input or something like that, it will go through this file. This one is to print errors. It does print errors in case your program crashes or whatever, and you can use it to print to the console. And there is this one, or to the terminal. So, and this one is the regular way to printing out to the terminal. And I think this one is faster. This happens through system calls, which is a big different topic. I'm just telling you roughly what's happening. So now what we are doing is we are printing out through this file that's opened in our program. We are saying hello world. Now, like you can see, this is it. We can compile this program by running go build main.go. This creates a main file. You can see it right here. And we can see the size. So ls, lh, we see the main. This is it. It's 1.8 megabytes. That's too much for a simple file, right? If you are coming, like I said, from C, C++ or something like that, this seems too much because Go is garbage collected. Go uses a method of like a garbage collection method. It's called mark and sweep. Again, this is deep topic. This is how Go manages the heap. Now, let's break down some of what we just said, especially about garbage collected or the garbage collector. It's also called GC. So for garbage collector, let's talk a little bit about it. Let's create a different function, even though this is a function call, and it should illustrate what I'm about to talk about, but let's write it right here. So func say hello. Let's paste that here, and let's say hello here, right? And maybe we do this. Okay, hello from main func. Okay, hello world. Now let's demonstrate how this works. So this is the disk. This is the hard drive. Here we usually store our files and programs. Let's say here we have a program. Let's say we have the file or program we created, the main, right? And here are the instructions. They live right here, or they are stored right here. They are almost dead. This is the hard drive. When we execute them, what happens? We take them, we copy them in the RAM. The RAM is smaller but way faster. Now there is here the CPU. This file, like the entire file with its contents and everything, gets copied right here. It goes to the RAM, and now we can execute it. How it gets here and the details, we will get on that. Wait with me for a minute, please. So now, unless the file is here, we cannot execute it here. The hard drive is very slow. It's not possible to execute files on the hard drive, as well as here it's close to the CPU to execute stuff, right? Let's say you are opening a photo or whatever file that you are editing, and this file is here. Let's say photo, this is the sun, this is the mountains. So this file, to read it, it has to be copied, all its contents here in the CPU. Then you can see it and you can edit it and do things, right? So this how programs works, whatever program, whatever phone or anything. So unless they are in the RAM, they cannot be executed. Now the RAM is very fast. So the RAM is very fast. However, here things can get interesting. There is a concept called caching. It's a memory where you can put things to get them in a way they are faster or closer to where they need to be. So they need to be executed or shown or whatever. So in the scope of a computer, the computer architecture, from the RAM to the CPU, there is 3 caches. There is the first one, it's called the L3 cache. Then there is L2 cache and then L1 cache. So these caches, it's where we store data to get them close to the CPU. And so when the CPU need them, they are like there is a fast execution to request them and get them instead of the RAM. So that's why this is the slowest, and all the way to this one, this is the fastest, also the smallest, also the most expensive per memory. So this one, maybe it's in the megabytes. So let's say 1 megabyte of this is the most expensive out of all of those. This one is so cheap, that's why we can buy 500 gigabytes or whatever. Now SSDs are of course way faster than all the spinning disks, but that's still very slow for us or for our computer. And this is roughly the mechanics. Now let's talk about our program. Now when we have the RAM right here, and this is the CPU again, CPU, our file or any program, when it gets copied to the CPU, it will allocate a page or something like that. It depends on other details. So our program, when gets copied to the CPU, we take the instructions, we copy them here. This is the code. Of course, this would be in the ones and zeros or whatever, but it gets stored right here. Now, this is called? It's called the stack area. So stack. Here, we will store variables that are like static variables and things like that we can use throughout all program or the package or something like that. They get stored right here. Then the main function, that's the function here, main. This main function, when it's executed first, we call this the activation record, because this one has the control over doing whatever we need to do in this program. This one can call other functions. When it calls different function, let's say hello that we did call, it will create another stack. Now this function, we did print something, right? So we did allocate some memory, that's here. If we did print something big, or maybe done multiple allocations of multiple things, we will allocate a bigger stack. So let's say we call all this with different data. This is a string, this is an integer, maybe this is an array, something like that. They are all here, okay? Now, once this function gets to call a different one, at that point, it will create a different stack, another one on top of this. It will give it the control. This control will no longer be here, it will be here. Here will become the activation record. This function, the say hello, it did say hello from a string, right? So this what happens. We allocate different stack, we put the string right here, and that's it. This one did print out to the console the say hello. So it did it. Once this done, this one was destroyed and the control was given back to the main. Main had nothing else to do, so it did exit the program, and that's it. So this is the execution. Now something happens. Sometimes, not sometimes, often we don't just need to call stuff from functions. We need variables all over the program or whatever. In these cases, we need heap allocation. Heap allocation, like stack, which has this first in, last out, LIFO, or last in, first out, whatever. So the stack allocation is different. There is the heap. The heap has nothing to do with the data structure called heap. Almost nothing, but it's like a bunch of space here in the RAM that we can allocate. Let's say we allocate this one and we put string in it. Let's say we allocate this one and put an integer or whatever. So we can allocate those. We allocate them dynamically. This is called dynamic allocation, and this one static allocation. This is the stack. So in the heap, we do not manage the memory. When we need something, we just create it. When we are done, our garbage collector that is shipped with the Go, it will take care of that and just delete it. How that's done, it's what's it's what's known the mark and sweep algorithm. So it will go through all this space, see what we are using and figure out what we are not using and just delete those. So this happens in a fraction of a second or whatever, and we will talk about this on different videos. But this is how it happens. This is why the file is 1.8 megabytes. If it was in C or C++, it will be a few kilobytes probably or something like that, because we don't have a garbage collection, we don't have a runtime and things like that. But that's the beauty of Go, and let's go. So thank you for watching, and these are some basics of how programs works in all languages and things like that, or computers and things like that. I hope you like it. We will dig in with more details on each of these in different videos. Thanks for watching, and see you in the next one.